So in this video I'm going to go through some sample questions for GCSE Physics forces. Question 1, the reading on a spring balance with a holder and 8 identical discs is 3.0 newtons. 6 discs are removed and the reading becomes 1.2 newtons. So here's the reading with the holder and 8 identical discs, the holder here including the dark bit, and this is just with 2 discs. So here's the weight 3.0 newtons, here's the weight on this one 1.2 newtons, so the change in weight is 1.8 newtons. Therefore the weight of one disc is 1.8 divided by 6 gives 0.3 newtons. So the weight of one disc is 0.3 newtons B. Question 2. Which statement about the masses and weights of objects on the Earth is correct? A balance can only be used to compare weights, not masses, where it depends what type of balance is and how it's calibrated and whether it's designed to read weight or mass, so that's not correct. Let's look at C. Large objects always have more mass than small ones. That's not correct because something could have different density. Lots of, anything made of different materials have different densities, so that you can have really small objects which are very heavy because they're very dense, and likewise you can have really large objects which are still relatively light because they're not very dense. So that's incorrect. Part D, mass is a force but weight is not. That's the other way round, so that's incorrect. So process of elimination, you know it's B, but let's just check B. Heavy objects always have more mass than light ones. Again, that's here, that you have to be just careful with that because, are you talking about density or not? But in this case, heavy objects always have more mass. Well, heavy is talking about more mass. More, if it's got more weight, there's got more mass because if it's in a constant gravitational field. So B is correct. Question 3. 2 objects X and Y are placed on a beam as shown. The beam balances on a pivot at its center. So that means that the moments about the pivot are equal to each other. So that means that the force applied by X multiplied by its perpendicular distance from the pivot is equal to the product of the force applied by Y downwards and its perpendicular distance from the pivot as well. So what does that show about X and Y? Well, it shows that they have the same mass and the same weight because the perpendicular distance is the same for each one. X and Y are the same distance away from the pivot as each other. It doesn't explicitly say that in the question, but you can judge that by eye that's correct. If you have a look at A, they have the same mass and the same density. Well, they might have the same mass, but they don't have the same density. X is going to be denser than Y because it's a smaller volume, yet it has the same mass, so it's got to be denser. B, they have the same volume. Well, they obviously do not have the same volume. X is much smaller than Y. And the same density, well, they don't have the same density. They have the same volume, no, and the same weight. Well, they have the same weight, but they don't have the same volume. So the only one that's correct statement is C. Question 4. In an experiment, 6 identical bags of flour are balanced by a 9 kilogram mass. Again, these are the same distance away from the pivot, we can assume here. 2 bags of flour are removed. What mass will balance the remaining bags? So first of all, we've got to say, well, 6 bags is 9 kilograms. Therefore, 4 bags is 6 kilograms. Because bags divided by mass rather, you've got 6 bags divided by mass. So 4 bags per mass. So X equals 6 kilograms. With this being the unknown mass of four bags. So they have to be the same as each other. They have to be equal to each other. So your answer is B, 6 kg. Question 5. 3 children X, Y and Z are using a seesaw to compare their weights. Which line in the table shows the correct order of the children's weights? Well, Y is heavier than X, Y is also heavier than Z, and X is heavier than Z. So Y is the heaviest, and then X, and then Z. Y, then X, then Z. So it's C. 6. The mass of a full bottle of cooking oil is 1.30 kg. When exactly half of the oil has been used, the mass of the bottle plus the remaining oil is 0.90 kg. What is the mass of the bottle? So mass of half a bottle of oil is 1.3 minus 0.9, which is 0.4 kg. The mass of all of the oil is 0.8 kg, and therefore the mass of the whole bottle of oil is 0.8 kg, and therefore the mass of the oil is 1.3 minus that 0.8, gives you 0.5 kg. 6b, if the density of the oil is 0.85 grams per centimetre cubed, what was the volume of the oil in the full bottle? So the density is the mass divided by the volume, so the volume is mass divided by density. So the mass is 0.5 kg, assuming you've got that correct, divided by the density gives you 0.59 centimetre cubed. And we'll have a look at density in our next video.